Hello and welcome. So in today's video we're going to be solving Chemistry GCE 5070 paper 1 variant 1 from the summer session of 2015. So let's get started. So our first question says the fractional distillation apparatus shown is being used to separate a mixture of two liquids. A thermometer is missing from the apparatus. Where should the bulb of the thermometer be placed? So we know that a bulb of a thermometer will never be placed directly in a liquid. It will never be placed directly near the fractionating beads, or else the temperature cannot be calculated. So C can be eliminated. It will never be placed in A because obviously the liquid is going to be evaporating, so it will never reach A. So A can be not answer. The thermometer will never be placed in the final liquid, so the D is not the answer. So our answer is going to be B. The thermometer bulb is going to be placed somewhere here so that it can detect the liquid temperature from that point. So the answer is B. The next question is the table shows the results of two reactions of an aqueous solution of a salt. What is the name of the salt? Okay, so for the reagent, sodium hydroxide in excess. So the final observation is a white precipitate. So not soluble in excess. So not soluble in excess. So not soluble in excess could be calcium. It will never be zinc. It could be aluminum. Dilute nitric acid with aqueous silver nitrate. A yellow precipitate is formed. Okay, so yellow precipitate means iodide. So we have iodide ions present in. So zinc cannot be a solution because zinc will dissolve in excess. Zinc will dissolve in excess. So chloride will form a white PPT. So chloride is also not an option. So the answer for 2 is going to be B. Moving on to the next question. Limestone reacts with hydrochloric acid. Changing which reaction condition does not affect the rate of reaction? Okay, so limestone is calcium carbonate reacting with HCl. So limestone plus calcium carbonate will give me calcium chloride plus water plus carbon dioxide. We have to put a 2 over here. Okay, so this is the equation reaction. Now, which change in constant condition does not affect the rate of reactions? We have a solid over here. We have a aqueous solution. We have a aqueous solution. We have liquid, and we have a gas. So concentration of the acid, yes, it will affect volume. It will affect rate. So it will affect the final volume of the products if the concentration of acids is removed. So limestone particle size, yes, this is going to be the surface area property of rate of reaction. So it's going to be the surface area property of the rate of reaction. This is going to affect pressure. So now we know pressure only affects gaseous compounds. Temperature, yes, we are going to have an effect of the rate of reaction because there will be much more or much bigger headlong collisions or successful collisions. So the answer is going to be C, since pressure only affects gaseous particles. The particle containing 34 protons, 45 neutrons, and 36 electrons. What is the symbol for this particle? So 36 means plus 2 more than protons. Therefore, the charge is going to be minus 2. So we're going to take a look at the particle with minus 2. This one has plus 2. This one is just minus. This has no charge. We've got 45 neutrons, so let's go and subtract 79 from 34. So 79 minus 34 is going to give us 45. So the charge match and the neutrons match with 34 protons. So the answer for this is going to be C. Moving on to the next question. Which molecule contains 3 shared pairs of electrons between 2 of its atoms? So carbon dioxide is drawn like this, right? Carbon shares 4. So 3 shared pairs. So this has 4 shared pair of electrons. So this is not the answer. C2H4. So this is an organic compound, and it can be written something like this. We've got the H's over here. Something like this. Let me just draw it a bit more cleanly. much more cleanly. Okay, so let's draw it over here. So C2H4. So C2H4 can be drawn like this. So 1, 2, 3, 4, 5, 6. So this is 6 pairs of shared electrons. So this and this can be eliminated. Let's try to do H2O. So we've got one oxygen combining with two waters, two hydrogens. So this can also be an answer because it's true. Now nitrogen, being in group 5, needs to share 3 pairs in between them in order to make a covalent stable compound. So the answer is going to be D, since it asks for 3 shared pairs of electrons. So the next question says, what happens when sodium chloride melts? So when sodium chloride melts, covalent bonds against a giant lattice is broken. So covalent bonds is not, this is it, ionic compound. So no covalent bonds are broken. Electrons are released from atoms. No, electrons are never released. We release intermolecular force of attraction. So molecular force of attraction. So we release that. So not electrons are not released from the atoms. Electrostatic forces between the forces of attraction between the ions are overcome. Yes, since it's an ionic compound. Molecules are separated into ions. No, molecules are never separated into ions. So the answer is C. Let's move on to the next question. Which compound contains only 8 covalent bonds? So for these, we need to break them down. Okay, so let's try to go ahead and break them down nicely. So this carbon is connected with one other carbon, and this carbon has 2 hydrogen atoms, followed by this carbon also having 2 hydrogen atoms. Okay, we cannot draw the hydrogen atoms like this for this carbon. You have to draw it over here. For this one also it's the same, so let's just erase that and draw it here. So 2 hydrogen atoms, and then we have this carbon with an OH group. So 8 covalent bonds. So let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 covalent bonds. So 9 bonds. So 7 has 9 bonds. So this is not an answer. So let's try to move on to the structure B. So we draw these two. So again, we have to draw 2 hydrogen, just like this, and it has 3 hydrogen over here, followed by an OH group. So 1, 2, 3, 4, 5, 6, 7, 8. So yes, this has 8. So this could be a possible answer. Now let's try to draw structure C. So we have C double 1, 2, 3 H with a C double O H. So this is a acidic group. So let's try to count the bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this has 9 bonds. So this is not going to work. Let's try to do D. C O H C H2 OH. So let's count 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Oh, so this has 7 bonds. Oh, sorry, it has 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 bonds. So this is also not the answer. So the answer is B. Let's try to move on to the next question. So this is question number 8. Which substance has metallic bonding? So when solid and when liquid, yes, it will conduct electricity. That means metals contain electricity when molten or solid because of the delocalized ions. State of product formed on reaction with oxygen. So, for example, calcium, it's a metal. If you react it with oxygen, it's going to form calcium oxide. Calcium oxide right here. So we're going to put a 2, 2. So as you can see, this is going to be a solid compound. So yes, it forms solid. Metal and air will never put a gaseous reaction a solid. But over here, as you can see in the conduction part, they both show they do not conduct electricity. So that means it's not possible. Metals always conduct electricity. So the answer is going to be A. Moving on to question number 9. A gas cylinder is placed in each of the 4 corners of a square room. Each cylinder contains a different gas stored under the same pressure. The gases are released at exactly the same time. Which gas will reach the center of the room first? So this one is more of related with the the molecular mass of the gases. So let's go ahead and try to figure them out. So nitrogen is 14 plus 3 times 1 with hydrogen. So it's going to be 14 plus 3 times 1, which is going to be 17. For carbon monoxide, carbon is 12 plus oxygen is 16, so it's going to be 12 plus 16, which is going to give me 28. Now let's go ahead and try to find it for chlorine. So chlorine is 35.5. Remember, I'm using the periodic table for this off camera, so you're also allowed to use the periodic table. 35.5 times 2, it's 71. So we can omit chlorine because it says center of the room first. So chlorine is like literally the heaviest among all of them. So we can omit chlorine. The only thing left is argon. So argon is an inert gas. It doesn't form any sort of diatomic molecules. So directly from the periodic table, we can say the MR of argon is 40. So for this, the answer for 9 is going to be A, because A has the lowest molecular mass, or MR. Okay, moving on to question number 10. Powdered calcium carbonate reacts with dilute hydrochloric acid to produce calcium chloride, water, and carbon dioxide. So let's go and try to write the equation reaction. So we have powdered calcium carbonate reacts with dilute hydrochloric acid to produce calcium chloride plus water plus carbon dioxide. We just have to put a 2 over here. Which is the correct ionic equation? So now we have to make this ionic. So let's go ahead and try to do this. It's a solid over here. We have got aqueous over here. We've got aqueous over here. All highlighted. So we've got liquid and we've got a gas. So calcium carbonate is going to remain solid. We can break down the H and Cl. So let's go ahead and write it. So we've got H comma Cl. We can break the calcium and chloride plus the water and the carbon dioxide remains the same. So from here, the only compound that we can remove is chlorine. So what is our final equation that we are getting? The final equation is going to be calcium carbonate plus 2H plus is Ca2 plus H2O plus CO2. CO2. So let's go ahead and see. So this one and this one is correct, so we can omit these two. And as you can see, this one is incorrect and this one is correct, since we have found out that we have an H plus group over here. So the answer for number 10 is going to be D. So question number 11. What is the relative molecular mass of this compound right here? So let's go ahead and try to find it. This is actually hydrated copper to sulfate. So let's go and try to find the relative molecular mass. So we've got copper, we've got sulfur. So let's go and try to write the elements down, okay? Oh, sorry, I moved the answer. So we've got copper, we've got sulfate, we've got O4, we've got H2, and we've got O. So now let's try to find this one first. So what about copper? So you're going to move on to the periodic table to find the MR of copper. So the MR of copper from the periodic table is 64, sulfur is 32, and oxygen, there's 4 oxygens, so 4 times 16. Plus, we have this dotted 5 before H2. So you have to put the dotted 5 notation to 2 plus 16, because hydrogen is 2 and oxygen is 16. So this value is calculated. So let's go ahead and try to calculate this value. So you can use a calculator to calculate this value. 64 plus 32 plus 4 times 16 plus 5 times 18. Yep, so 5 times 18. So the answer is 250 MR. So answer is D. Alright, so let's move on to the next question. Question number 12. 1 dm cube of ammonia gas is produced. Gas is passed over heated copper to oxide. So ammonia is reacting with copper to oxide to produce or to decompose to copper, nitrogen gas, and water. What is the volume of nitrogen formed when measured at the same temperature and pressure as ammonia? So as you can see, so the volume of nitrogen forms, so we have to find the volume of nitrogen gas. Now we are comparing gases, so you can directly use the molar ratio formula, but I'm just going to go ahead and continue doing it in the regular molar way. So first we have nitrogen. We have to talk about nitrogen. Sorry, ammonia gas, not nitrogen. So let's try to deduce some details about ammonia gas. So let's try to find the moles first. The same temperature pressure as ammonia. What is the volume of nitrogen gas? Okay, so let's see what you can do. So we know moles is volume. So volume is 1 dm cubed by 24. So 1 by 24 is going to give me 0.0417 moles. So this is this many moles. So now we have to do a molar ratio comparison between these two. So we have to do the molar ratio comparison. So this is 2:1, 2 and 1. Now we do know the volume of ammonia, but we don't know the volume of nitrogen. So what is it going to be? It's going to be, if we just try to calculate the ratio, it's going to be 1 by 24 divided by 2. So 1 by 24 divided by 2 is going to give me 1 by 48 moles. So now what is the volume of nitrogen produced? So we know, to calculate, we know moles is volume divided by 24. So what is the volume? Volume is moles times 24. So it's 1 by 48 times 24. So 48 times 24 is going to be 0.5 dm cubed. So the answer for 12 is 0.50 dm cubed. Let's move on to the next question. So question number 13. What are the correct anode positive electrode and cathode negative electrode products when aqueous copper disulfate is electrolyzed using copper electrodes? So let's go ahead and try to look at this question. When using electrolyzing copper electrodes. So copper electrodes is an active electrode. So the anode product, so what's going to happen? The anode is going to break down, and this is going to build up. This is a theory that we learned. So now let's go ahead and try to deduce a little bit. So let's go and try to first talk about the anode. So what's going to happen in the anode? The copper is going to break into copper ions, releasing electrons, releasing 2 electrons. What's going to happen at the cathode? The cathode is going to be gaining electrons, or the ions are going to be re-decomposed to the cathode to form copper atoms. So cathode product is going to be copper metal, not hydrogen gas, and the anode product is ions. The ions are going to break. So the answer for number 13 is going to be A. Let's move on to question number 14. Concentrated aqueous sodium chloride is electrolyzed using inert electrodes. Okay, so we've got inert electrodes. Which statement about the electrolysis is correct? Okay, so which statement about this electrolysis is correct? So inert electrodes, and this is an aqueous sodium chloride solution. So for the cathode, since it's aqueous, we're going to be having H plus 2E minus is going to give me H2, hydrogen gas. And it's copper to chloride, so the chloride ions is going to be gaining to form chlorine gas. So chloride ions travel through the solution to the negative electrodes. Electrons travel this, okay, no, electrons never travel. Gases are given on both electrodes, yes. Sodium is formed in the negative electrode, no. Now, why is A not an answer? Chloride ions travel through the solution to the negative electrodes. No, chloride ions travel to the anode. So anode is the positive electrode. So the answer is going to be C. Moving on to the next question. The diagram shows the energy profile of a chemical reaction. 2 energy changes are labeled X and Y. Which statement about this reaction is correct? Okay, so what is X? It's going from the reactants to the peak point. This is known as the activation energy, or EA. And from the reactants to the products, on how much energy change is taking place, is known as the enthalpy change. Over here, it's a negative enthalpy change since it's an exothermic reaction. So let's also write it exothermic reaction. Now let's try to deduce what's in the answers. Which statement about the reaction is correct? The activation energy of the reaction is x plus y. No, it's just x. So the answer is not A, so it's incorrect. The enthalpy change for the reaction is x. No, the enthalpy change is y. The enthalpy change for the reaction is x plus y. No, the reaction is exothermic. Yes, because products has less energy than reactants. So the answer is going to be D. Moving on to the next question. In the graph, curve 1 was obtained by observing the decomposition of 100 cm cube of 1 mole per dm cube of hydrogen peroxide solution catalyzed by manganese 4 oxide. Okay, so this is the reaction. Hydrogen peroxide is going to water, and so the volume of oxygen formed. Which alteration to the original experiment conditions would produce the graph of curve 2? So as you can see, if we try to go ahead and measure the rate of reaction of curve 2 and compare it with curve 1, as you can see, this is curve 1, this is curve 2, at the same time period. At the same time period, this is curve 1, which has a higher volume of oxygen compared to curve 2. So curve 1 is at a higher rate but low yield. So adding some 1 mole of hydrogen peroxide solution to it. So we're just increasing the concentration. So increasing the concentration should technically also increase the rate of reaction, which did not happen in this case. The rate of reaction decreased, but the volume of the acid is produced. Okay, so for number 16. Lowering the temperature. So if you lower the temperature, we can only see the rate of reaction is going to decrease, but we're going to achieve the same volume. So this is definitely not an answer. Using less no, catalyst never affects the volume of the reaction. So this is not an answer. Using a different catalyst, no. Again, catalyst will never affect it. So the answer is A, because even though we're adding some more of these, we are actually making 100 cm cube of the manganese 5 oxide a limiting reagent. Okay, so this 100 cm cube right here, this is limiting reagent. So since this is a limiting reagent and we're limiting it, so we're going to be getting a lower rate of reaction but a higher volume of the water. So the answer is going to be A. Moving on to the next question. The equation shows a redox reaction between iron 2 chloride and chlorine gas. Which equation describes the reduction process in this reaction? Okay, so as you can see, chlorine is losing electrons. So loss of E minus, which is oxidation. So this is not an answer. Then we have chlorine, which is gaining electrons to form chloride ions. So we have the gain of electrons, which is reduction. Okay, so iron 2 is losing an electron. So we have loss of electron. So this is oxidation. Now iron 3 is gaining an electron over here to form the Fe2+. So again, we have a gain of electron, which is a reduction. So now we have two reduction process in question number 17. Okay, so now why is this not a process of reduction? So we need to look at the original equation in this case, right? Original equation. So as we can see, we are requiring 3 more chlorine, right? So Fe3, so this is a plus 3, right? It's a plus 3. So this over here is not related to the equation. So this cannot be an answer. So the answer for 17 is B. Okay, question number 18. Which row correctly describes these oxides? So aluminum is a amphoteric oxide. So C or D is the answer. So this is wrong. Potassium is just basic. So this and this could be a possible answer. So D is also gone. So I can safely assume that answer C. Or is it? Then we have magnesium, and then we have sulfur. So, oh no, this is actually correct. So this could also be basic. So the answer is not C, not C. Let's try to read it a bit. So magnesium is not amphoteric. Sulfur is acidic, but it's not, magnesium is not amphoteric. It's a metal oxide which is basic, just like potassium. So the answer is D. Which substance is insoluble in water? So we know all ammonium salts, ammonium carbonate included, are soluble. This is soluble. Ammonium nitrate, again, both of them are soluble salt compounds. Calcium carbonate, calcium nitrate, so all nitrate salts are soluble. Calcium carbonate is not, because only sodium, potassium carbonates are soluble. The rest of all carbonates are soluble except sodium, potassium, calcium, and barium carbonates are not soluble. So the answer for 19 is going to be C. Let's look at question number 20. In which of these equilibria is the forward reaction favored by an increase in pressure? So increase in pressure. So increase in pressure means only gaseous compounds. So in all of these, we just have gaseous compounds. So that doesn't make sense to look at which compounds are gaseous. So now let's take a look at the amount of particles in each side. So on the left hand side, we've got 2 particles. On the right hand side, you've got 2 particles, in which of the forward reaction favored by increase in pressure. So if you increase in pressure, no change will occur because both the left and right hand side have the same amount of pressure. So increasing the pressure will just refer to the side of where the pressure was increased, or overall pressure is going to increase. So let's take a look at this side. So we've got 1 particle by 2 particles. So if we now increase the pressure, it's going to refer to the side that decreases the pressure. So that's going to be the less number of particle size. It's going to prefer the left-hand side. So the answer is not going to be B. Next, we have 2 plus 1, which is going to be 3 particles by 2 particles. So let's take a look. If we increase the pressure, yes, it's going to refer to the side with less number of particles. So it's going to refer to this side. So C could be an answer. Let's take a look at D. So we've got 1 gas molecules, 2. So if we increase the pressure, it's going to shift to the left-hand side. So D is not an answer. So the answer for this equation is going to be C. Okay, so moving on to the next question. The contact process, the Haber process, and the hydrogenation of fats all involve the use of a catalyst. Which row correctly describes what the catalyst used in each process, an element or a compound? So in contact process, so what do we use in contact process? So contact process is the manufacturing of, sulfuric acid. So over here we use vanadium 5 oxide. Vanadium 5 oxide. So it's V2O5. So for contact process, it's a compound. For Haber process, we use iron. So it's an element. For hydrogenation of fats, we use a nickel catalyst. So nickel catalyst is an element. So the answer is B. So for contact process, it's vanadium. For Haber process, it's iron. And for hydrogenation, it's a nickel catalyst. Which element is sodium? The sodium has a melting point of 98 degrees Celsius. It's like a book note. But let's go and take a look at this. Sodium is soft. It can be cut with a knife. So it's never going to be A or B. Now it could be C, but we have electrical conductivity of poor. Sodium is a metal. So it has a good electrical conductivity. And it has a relatively low density as it floats on water. So the answer is going to be D for 22. So question number 23, a non-metal element forms oxides of the type of XO2 and XO3. A non-metal element forms oxides of the type XO2 and XO3. What is X? So these two suggest that it has a variable oxidation state. So what does a variable oxidation state refer to? So it cannot be aluminum, or can it? It cannot be carbon, Let's see. So it cannot be aluminum because aluminum is at fixed +3. It cannot be carbon. So can it be hydrogen? No, obviously they're going to put a +2 and +3. Now can it be sulfur? Now the thing is, yes, it could be sulfur. Why could this be sulfur? Well, so sulfur is S2 or S3 minus. This is a differentiated property of sulfur, so the answer is D. So let's take a look at question number 24. Aluminum reacts with chromium 3 oxide as shown. Aluminum plus chromium 3 oxide is equal to chromium plus aluminum oxide. Which statements are correct? Aluminum is more reactive than chromium. So I don't think so aluminum is more reactive than chromium, or is it? Yes, aluminum is more reactive than chromium because chromium is a transition metal and aluminum is a +3 grouped metal. So aluminum is more reactive. A similar reaction will also take place between aluminum and iron 3 oxide. So as you can see, so aluminum with iron 3 oxide is going to form aluminum oxide plus iron. So yes, a displacement reaction takes place. So this answer is correct. Iron 3 oxide is reduced by another metal in blast furnace. So iron 3 oxide is not reduced in blast furnace. Only the calcium and the slag is reduced. So this is not an answer. So the answer is B. Moving on to the next question. Using the periodic table for the relative atomic masses, which has the least mass? Okay, so this many moles of silicon dioxide. Okay, so now we have to do the molar calculation. So 0.1, okay, this we're doing this for silicon dioxide. So we don't know the mass. So we have to look at the periodic table once again to find the mass of silicon. So we're just going to go ahead and take a look at the periodic table. So silicon is Si. So I just have to search for silicon. So got it? Silicon is 28 plus 16 times 2. So the mass is 0.1 times 28 plus 16 times 2, which is going to give me 60 times 0.1, which is 6 grams. Now let's take a look at 0.5 moles of 2 times 16, which is oxygen. So the mass is 0.5 into 2 times 16, which is 16 grams. We're going to put 16 grams. So lithium, so 0.5 moles is again, so for lithium, the mass is 7. So times 7, which is going to give me 3.5 grams. So it's 3.5 grams. Least mass, again. So for ammonia, it's going to be 1 moles mass times 14 plus 3. So mass is 14 plus 3. So I guess nitrogen is 14. Yeah, it's 14. So it's going to be 17 grams. So this is 17 grams. So as you can see, this one has the least mass. So for 25, the answer is going to be C. Okay, let's move on to the next question. The diagram shows an underwater iron pipe that can be protected from rusting. Okay, so metal Z can be 1 because it is too reactive than iron. Okay, so metal Z can be something that is more reactive than iron. So 2 is definitely more. So nothing with less. We've got more. Now copper is definitely not more reactive than iron. So let's go into write. So this is a reactivity series. So as you can see, copper is less reactive than iron. So this copper thing is not going to be the answer. So the answer for this is going to be B. Moving on to 27. Brass is an alloy. Which statement about brass is correct? It contains a sea of electrons. Yes, it could be an answer. It contains positive and negative ions which are free to move. Nope. Brass is an alloy, so it's a mixture of metals. It is a compound of metal and non-metal. So no, generally we only mix metals with the alloy. We do mix carbon, which is technically a non-metal, but carbon is used just for strengthening. But in general, we do have C of electrons in an alloy. It is a compound of two or more metals. So it is not a compound, it's a mixture. So the answer is going to be, for 27A. Let's move on to 28. Which item is made from mild steel? Okay, so it's mild steel, so less amount of carbon. It can be dented or stuff. Want to store gas in chemical plant. No, it's made of high carbon steel. Scalpel is for operating theater. Scalpel is in operating theater. No, it's also made of high steel because it needs to be durable. A set of cutlery is made of stainless steel, not mild steel. So the answer, so this is stainless, this is high, and this is high carbon. So the answer is going to be A. Okay, so the table shows the composition of an exhaust gas of an internal combustion engine. What is gas Y? So we've got gas Y, which is 71%, 71%. So for 29, so gas Y must be an abundant gas, which is nitrogen gas. So the answer is going to be D. Which two gases do not change which do not damage limestone buildings? So nitrogen, carbon monoxide doesn't. It's just poisonous. But nitrogen causes acid rain. So it does. So this also causes acid rain. This also causes acid rain. Sulfur dioxide also contributes to acid rain. Carbon dioxide does not contribute to acid rain. It just contributes to global warming. Nitrogen dioxide also contributes to acid rain, but just plain nitrogen does not contribute to acid rain. I'm sorry. So plain nitrogen does not contribute. Dioxide, so which is NO2, contributes to acid rain, and SO2 also contributes to acid rain. So carbon monoxide and nitrogen. Iron trioxide can be reduced to iron by carbon. What other element can reduce iron trioxide to iron? So something more reactive than iron, so more reactive. So no, I didn't write the table over here. So lead is so kind of like so as you can see, lead is less reactive than hydrogen. It's not going to happen. Copper is not going to happen. Silver, no. So this is the answer is going to be C. Ammonium salt was added to excess aqueous sodium hydroxide. So an ammonium salt, so it could be any ammonium salt. Ammonia gas was evolved. There was no more ammonia involved. Aluminum is added to the solution remaining, and more ammonia gas was given. So a ammonium salt reacts with hot aqueous sodium hydroxide. Okay. So what if we use NH4Cl and hot aqueous sodium hydroxide? So aqueous sodium hydroxide. So it's going to give me NaCl plus NH3 plus H2O. Now if we add aluminum, what is going to react with aluminum? No reaction. In general, there is going to be no reaction, so this is not going to be an answer. Moving on to NH4NO3 plus NaOH is going to give me NaNO3 plus NH3 plus H2O. Will this react with aluminum? Yes, to produce a nitrogen gas, which then reacts with the NH3 to form NH4, which is ammonia. So the answer for this is going to be B. Okay, moving on to the next question. Two esters have the same molecular formula. What are the names of these two esters? Okay, so we have methyl ethanoate. So methyl is the alcohol and ethanoid is the acid. So let's try to draw the ethanoid group. So methyl will only have one carbon, and eth means two carbons. So we're going to be drawing this. Okay, so this is methyl ethanoate. Methyl ethanoate. So you have 1, 2, 3. 1, 2, 3. 4, 5, 6. 1, 2. So yes. Next we have ethyl propanoid. So let's try to go ahead and draw it. So first we need to draw propanoic acid. So prop means we have 3 H 1, 2, 3, 4, 5. We already have 5, and then we have ethanol 1, 2, 3, 4, 5. So this is not an answer. Then we have ethyl methanoate. So this is just the reverse. So this is going to obviously be an answer. So propyl methanoate. It's just the opposite. So for 33, the answer should be 1 and 3. Moving on, which statement is correct? Carboxylic acids contain the functional group this. Nope, the functional group is actually like this. Or if you want to draw it, something like, oh no, it's wrong. It's something like this. So this is not an answer. Ethanoic acid will fizz and react with when copper is added. No, because this is a weak acid and generally copper metal doesn't react. Ethanol will decolorize acidified potassium manganate. So it's an oxidizing agent. So yes, the structure of ethyl ethanoid is this. So let's try to draw ethyl ethanoid. So we need to draw ethanoic acid first. OCC. So as you can see, this is also wrong, this is also wrong. The structure of this is actually methyl. This is 1 carbon methanoid. Methyl methanoid. So the answer for this is going to be C. When cracked, 1 mole of compound X produces 1 mole of propene and 1 mole of hydrogen. Okay. So propene. So it could be an alcohol because if we... Oh, it's catalytically cracked. So it produces a alkene and H2, and when it's cracked, so it's definitely an larger chain alkane. So for 35, I believe the answer is going to be B because it's got to be a larger chain alkane. Which is a correct definition of isomers? Atoms with the same relative molecular mass, and different structures. Yes, or technically no, because it says the same relative atomic mass. Compounds with the same molecular formula but different structure, yes. Compounds in the same molecular formula with molecular mass, no, it could be different structures, so this is wrong. Elements with the same molecular mass and same structures, no. So the answer is going to be B. Finally, at the last page of today's video, which of the following has not been prepared by reacting a carboxylic acid with an alcohol? So which has not been prepared by reacting a carboxylic acid with an alcohol? So let's try to take a look. So we've got a carboxylic acid with an alcohol. So what happens when carboxylic acid reacts with an alcohol? We form an ester. So we have to look at the ester linkage in all of these. So right here we have ester linkage. So we have no ester linkage. Over here, yes, we have an ester linkage. So this carbon is probably inside. So we have COO. Yes, we have the ester linkage, the COO group. So this one only has one O. So the answer is C. Which of these polymers is a protein? So protein is polyamide. So chlorine is definitely not an answer. Yes, we have a nitrogen. So if you draw two C's, 1, 2, 3. So you've got 2 carbon. Okay, so this is not the structure. I'm just trying to draw the structure over here. So you've got a carbon, which has, so if you have a nitrogen with this, so as we can see, we have a nitrogen compound over here with a CHO group with a polymer indication. The answer for polyamide is going to be D, because the amide linkage goes something like this. It's NH connected with CO. So this right here is amide. So let's move on to question number 39. In the additional polypropene, what is the simple ratio of carbon atoms to hydrogen atoms? So what's propene? So propene has got to be CH3H6, so it's going to be CH2. So the simplest ratio should be 1:2. So 39 is going to be A, 1:2. Which statement about vegetable oil and margarine made from is correct? Both are liquids. No, vegetable oil is liquid, margarine is solid. Both occur naturally. Nope. Margarine has a higher melting point. Yes. Vegetable has a fewer carbon double bonds than margarine. No, vegetable oil is a saturated compound. So the answer, vegetable oil is saturated. So for this, the answer is going to be C. So I hope you enjoyed the solution of this paper. Hope I could help to practice a little bit. Hopefully I'll be coming up with a new paper very soon in a future video. Until then, catch up in the next video.